MQA Certification UK Ltd, presented. Lean Six Sigma Green Belt Training Day 2.
Then we covered the roles and responsibilities. Then we went for the define phase. In define phase, first of all, we have seen the project charter. We have seen process mapping through SIPOC study. We have seen voice of customer. We have seen voice of a customer, like customer into translation matrix, project monitoring and tracking. So this was define. So define phase was basically like what we want to do, like where we want to like do the improvements. Like everyone is aware that Six Sigma basically started with Motorola 1987 and it was slowly adopted by various companies. Now the basic history of Six Sigma is it is an American concept which was adopted by Japanese. Basically it was American concept, not a Japanese concept. So we talk about like benefits of Six Sigma where we talked about variation in reduction. See basically in any project we have lot of variations. What is variation? Deviation from the standard. So we have to identify the variation, we have to reduce the variation. Then in certain cases of productivity projects, we have to reduce the cycle time. We have to reduce for our good customers, we have to reduce the defects. For good customer, we have to reduce the cost so that we can be competitive. If we are good in our product and cost, then our market share also grows. If everything grows, cost customer happy, supplier happy. If supplier happy, customer happy, we will have new products. So we will have new product developments. We will have reduced customer resource consumption. Like resources can not only be man. Resources are like man, machine, material, methods. So most of thing can be like we can improve on that. Our yield and productivity has to improve. And rate of like we have to accelerate, not only improve. See, if not only we are doing 2 projects, 3 projects, we are stopping. We have to be continually improving, continually. There is a continuous improvement is the word which is basically used. Do a first level of project, then go for the next level, then go for the third level, complete the third level, go for the fourth level. So this was the basically.
Apologies, sorry.
Pardon?
I was saying apologies for switching on the camera. Sorry about that.
Sure, no issue. Do you have any doubts?
No, sorry. No. I'm okay. Carry on.
Okay.
Carry on.
So I was basically talking about the phase 1, the day 1. Now we will continue for the day 2 if all are comfortable. If anyone has any doubt. So day 2 agenda, like we will see the data. What is data? Because understanding the data is very important. Now data collection plan. We have to understand the data. We have to make a plan what data has to be collected because data collection is very expensive job. Time consuming, expensive and hectic. So we have to like detailed process mapping we have to do. We will study various concepts of DPO, DPMO. What is baseline? Can anyone give idea about baseline? What is meaning of baseline? Can anyone?
More or less like setting a standard.
Baseline, yeah, setting a standard, but there are various methods of going into baseline. Like we have our competitor baseline, we have a market baseline. So like for mobiles, everyone has a cost based on the features. Everybody has a cost baseline because today's market is very competitive. Then Six Sigma yield table. So everybody knows that we have like 3 sigma, 1 sigma, 2 sigma, up to 6 sigma. So different sigma level have different rejection yields, rejection rates. And when we go for rejection, calculate the rejection rates, we can get the yields. We have first pass yield, we have throughput yield. Then we will go for MSA and SPC to understand the concept. So now on the day 2, we are into measure phase. So what are the data types? What are the Six Sigma metrics? Measurement, system analysis, MSA, and process capability. So what is measure? Measure means we have to measure. Now there is an important concept like why we have to measure. So why we have to measure? Because unless we know where we are standing or where we are at the current level, how will we know that where we are as compared to the standard companies and where we want to go? So measurement is very important. So in measurement, define the opportunity, defect, opportunity, unit, and matrix. Matrix means measurement systems. Detailed process map. Process map is basically what we have to see is analysis, like as what has to be done and what we are doing. Develop a data collection plan. Validate measurement system analysis. We have to collect the required data. Process capability and Six Sigma baseline. Baseline we stored. So we talked before only that we have to benchmark basically. Benchmark can be with respect to market, with respect to cost, with respect to productivity, with respect to features, we can benchmark. Then redefine the project goal. Sometimes we define the project goal, but during the measurement phase, we feel that we are okay or we don't have much scope. Then we have to decide that redefine that the what level of improvement we are defining is, whether it is more, whether it is less, whether it is smart or not. Specific measurable goals are basically, when we talk of goals, we say a concept called SMART, which SMART means goal should be specific, measurable, achievable, realistic, and time bound. So everything has to be the part of goal. Then redefine the financial estimation, because when we are doing a Six Sigma project, initially we do a budgeting for the cost. So we have to redefine, because presently we have defined only what we want to do, but when we measure, we actually know where we are and where we want to go. So maybe chances that our financial estimation will go up or down, whatever it is, and the management will decide whether to move, not to move, whether we will take time next time, or like this project has taken immediately, or it will take after some time. And that all thing decisions will be done by the management. And basically, finally, we have to identify the current performance, where we are, what we are doing. So measure is basically measure. See, key to improvement point is, I told that if we cannot express what we know in numbers, we don't know we don't know much about it. Means when we don't know the value of that thing, then we don't know the actual value, or we don't know anything. Suppose we are measuring a particular parameter, and we don't know what is required, or we cannot give a number to it. Then we don't know what we are doing. So if we don't know much about it, we cannot control it. Initially, I told you, to control anything, we have to measure it. We have to measure it, understand where we are standing first. Then only we will understand where we are wrong and how can we control it. If we can control it, then we have a chance to win. Here it is written that if we cannot control it, so we don't have any chance. We are on the mercy of the process. What is happening, let it happen. But we have to measure it so that we can control it. And measurement is basically in terms of numbers. What is the what is the defect, losses in the defect, what is losses in the production time, what is the losses in the manpower, whether the manpower is sufficient or not, or capable or not. We need to invest in manpower. So a lot of things are there. Now measure. When we talk about measurement is always cost. Why it is a cost? Because measurement needs material to measure. We need tools, equipment. We need nowadays, if you want to measure something in terms of finance and all, we need softwares and all. So we need material. Then we need time to measure. Time to measure in the sense, first of all, we have to know what to measure. We have to learn how to measure it. And then it takes time to take any measurement. Because in Six Sigma, we don't have to measure, like example of manufacturing, we don't have to measure 1 piece or 10 piece. We have to measure approximately like 2 shift production, 5 shift production, or 5 days production. Then only we can get the real picture of the data, because in 1 hour production run, we cannot measure anything. Like man to man variation, we cannot measure. Machine to machine variation, we cannot measure. Time to time variation, we cannot measure. Even day to day variation, we cannot measure. So a lot of things are required. So initially it takes it takes a week time to measure, because if we invest more time in measurement, if we give little more time in measurement, then we can evaluate that things properly. And I told you resources, like material we already considered, but we have to consider the resources also, because measurement is not a easy job. In measurement, we need a qualified resource. Not everyone can handle software. Not everyone can handle every instrument. Not everyone knows the process. So people are also important. Their capability and their willingness to do is also important. So ultimately, it is a cost. That's why we call it now when we see the cost of quality in any manufacturing. So measurement is also a cost which we calculate. Now when to measure? So like we should know various things, like we have a 4W1H approach, like what to measure, when to measure, where to measure, how to measure, and how much to measure. So these are very important questions to be answered before deciding on measurement. So first is input measure. Measures of factor provided by supplier to the process. Okay. Means what are the process parameters which is input to the process. Like everything is, we are just converting raw material into finished goods. So in raw material, it is coming from supplier. Supplier is doing some processes and sending to us. So we have to measure the raw material. Process measures. Process measure means basically it is a in process measurement. Like suppose we have different parts, we are doing assembly in our plant. So measure that internal to your process. We are doing in process inspection. We are doing in process approvals. Like assembly inspection, assembly approval, packaging approval, dispatch approval. So these are all in process. Then output measure. Now output measure is like when we send the parts to the supplier. So how customer service is being measured. In basically ISO, it is very important. And without that, no ISO audit happens. Like we have to have customer feedback. Customer survey, customer feedback, customer visit is very important, because customer is the final one to decide whether we are good or bad. If our customer is happy, we will get the business and we will be happy. So output of our product and services, which is determined by the customer, and we are meeting it or not. So there are three things. Now if we go for data types, we collect data for two purposes. One is for information. Like sometimes we need the information, like sometimes we have a legal data. So why we collect the legal data? Because legal department requires it. Government body require it. So it is for information. Sometimes we collect data for knowledge. Knowledge in the sense it is a process of learning. Like when we develop a new product. So we do initial We do all the things in the initial level, like initial control plan, initial inspection, initial everything. We do initial capability study to understand and get knowledge from it, where what is going on, and it will give us knowledge of our process, where our process is standing at the time. Now data. Data are of two types. Can anyone tell me what is continuous and discrete? Hello? Can anyone please? What are types of data we have?
Quantitative, qualitative.
Can you give in the simple words? Can you say in your own words? See, it is like simple words is continuous and discrete. We call it continuous, we call it variable, and discrete we call it attribute. So continuous data means like we are measuring a length, we are measuring time, we are measuring temperature, we are measuring cost. So we are getting a particular number for it. Number in the times, how much meter it is, how much hour it is taking, what is the temperature it is reaching, what is the value in terms of rupee, in terms of like financial terms. And discrete data is like, it is like yes or no. It is like a decision making. We call it a decision making. Like we have in our manufacturing also we. Yes, please.
What if we say qualitative and quantitative?
No, I just want to understand that it is the one and the same thing, but I want to understand that examples also.
So examples of quantitative. Quantitative data is one that you can measure, like temperature. You know, it has a value. Quantitative has a value.
Yes.
Yes. However, the qualitative is like if you're studying a population, what is their behavior? You know, like it is not, there's no parameter that you can measure directly and it gives a value. However, the quantitative, you have a value.
Yeah. See, I was telling that only. If you see continuous, okay, then it is quantitative. Then we have like we call it variable data also. There are many terms used for the same thing. Continuous, variable, quantitative are one and the same. Discrete is like we call it like attributes. Like if we go to a shop, if we pick some from a shop we will go to buy something. So there are only two decisions which can be done. Either you will buy or you will not buy, right? So it is like yes, no, pass, fail, good, bad. So this is like discrete or attributes. And like measurement is different for both of the things. So hope everybody's doubt is clear.
Yes, it's clear.
Now see, it is continuous, time, scale, discrete, like we use in the shop floor. It is called go no go gauge. Good, not good. One end is good, it should go. Other end is not good, it should not go. See in the torch, either it is working, it is not working. People are happy or people are not happy. Now, as discussed, the same thing, like we have for the parts, like it is accepted or rejected. First to quantify is like whether it is good or not good. Then second is continuous data or variable data. We measure it with respect to various parameters like spread of the process, the central tendency of the process. When you see this graph, Is my cursor visible? Can you see my cursor?
Yes.
Can you
Yes.
see? Yeah.
Yes.
See, this is like, we call it lower specification limit. So suppose lower specification limit is lower value of tolerance. This is upper specification limit. So within this is 1. This area is 1. This dotted line is the center line. So like we can see the data is centric, is near to the center line, and 90% is covering within the USL and LSL. So this is the thing which we are talking about, the data example. Now we have certain things to determine, or we call it principles for collecting the data. So first is define the data goals, like what we want to collect. So I told you W, H and all principle. So here everything defines here. Okay, why you are collecting the data. First of all, why you want to collect the data. Then what type of data you need to collect. Third will be like what will you do with the data once you have it, because it determines the importance of the data. Then how will the data help you? So these, unless I know this parameter, we cannot define, or we cannot give importance to the data collection. Then define the definition. To remove ambiguity. Ambiguity means, suppose I said someone to measure the length, but the person don't know which unit he has to measure, whether he has to measure in mm, whether to measure in inch, whether he has to measure in decimal point, single digit, the 0.0102, which instrument, like what is the accuracy level required. So a measure definition is a precise description that tells you how to get the value of the character you are trying to measure. So we should know what are the characteristics of the parameter we want to measure. It should include something is and how to measure it. Like what we want to measure and how we'll measure. Then data variation. Now variation is a part of process. It is inbuilt also, like every manufacturing, every activity, every service activity, you will not get the same level. Even in the case of service activity, you will not get the same level of service every time. So same in the manufacturing also, you will not get the same data every time, like same accuracy every time. So data variation is, understanding the variation is also important. What causes the measurement to vary? Like why measurement can vary? How can I reduce the impact of measurement? Then test or pilot your chosen data collection method. Like before we are collecting the data, because we will not collect the data, we will ask the technicians to collect the data. So before asking them to collect the data, we have to collect few data so that we can understand the methods we have told them to measure or collect the data is right or not. So we will understand when we collect the data in the initial samples, then we'll understand whether the process is right or something has to be, like method has to be changed. Is there requirement of a special person, knowledgeable person, special instrument? So lot of things will come to know. Then we will collect the data. In collection of data, we make sure everyone collecting the data has clear instruction. Now here is like I told you, we will be delegating the responsibility. So delegation principle is very important, that even though the technician is collecting the data for us, but who will be responsible for the data? If technician is doing any error, then who will be responsible? We will be responsible because we are delegating it. So delegation doesn't mean that we are just telling him to measure. We have to ensure he is measuring it rightly and giving us the right data. So make sure everyone collecting the data has clear instruction. So to collect the data properly, he should understand, the technician should understand the purpose of the task, that why we want to collect the data. Understand the purpose of the task. Then second is ensure the data collection procedures are error proof as possible. Like there should not be like it should not happen that one technician is collecting the data in different way, other technician is collecting data in different way, then we will have two sets of data with variation. Because data collection is also a skill, talent, experience, knowledge based. So we have to understand that. Be present at the state and lead the period where the data is being collected. So as I told you, be present at the start. Means when the technician is collecting the data, we have to see for the few samples how it is doing it. And lead the period where the data is being corrected. As far as possible, spend the time with the technician so that he will collect the data properly. Now we should have a data collection plan. So data collection plan has, like we call it 5W1H. So 5W1H is like what? What in will ask you what need to be measured. Now define the parameter. Definition is in terms of parameter. So what parameter we need to measure? Like sometimes it is very confusing in the drawing. People don't know. People are not able to read the drawing properly, understand the tolerance. So we have to define them properly. There are some indirect things which needs to be defined, like formulas. So like we will be taking the like we will be taking some parameter and then putting into formula and then collecting it. So we need to understand these three things. In what? In why purpose of collection of data, like why the data is required. Then third is when. When means the data cannot be collected anytime. We need to understand like date, time and frequency. Like while doing the SPC and all, we do like we collect the 5 samples every 2 shifts. Every 2 batches of 5 samples every shift, and we collect all the shifts. So that way we to understand ki when we have to collect, at what frequency we have to collect. Because 100% data is not that we are collecting 100%. We are doing sampling. So date, time and frequency for sample is very important. How we know that collection method? What is the collection method for collecting the data? Then where is the source? Where means which process we have to collect the data, because sometimes it happens that some parameters are maintained at different places. So we should know which stage of manufacturing we have to collect the data. Then who? Then who means we have to identify that who will collect the data, who is capable of collecting the data. Data collection plan example. Now we have seen the definition, like ideas. Now we'll see the examples. Like what needed to measure, we need to measure delivery time. So what is our data? Example here, data example is delivery time. So what is delivery time? Delivery starts from the customer at one location, places a package in out box. Okay? So it is delivery time. Delivery finishes when the customer at another location receives the same package. So this is delivery data. One customer is giving, another customer is receiving. So delivery time is time packaging received minus time packaging sent. Like we are doing, like nowadays we have an online Ola, Uber systems and all, where parcels are being transferred by the delivery guys. So when the delivery guy picked from one customer and when he delivered to the other customer, that is the delivery time. Package sent and received. Then to develop the baseline of delivery time and track the efforts to reduce it by 50%. Now why are you measuring the data? Because delivery time may be high. So we are feeling the pain of high delivery time. So our aim is to reduce the delivery time by 50%. When? Pick up all the data Monday to Friday before 5 p.m. Now this time frame is considered 5 p.m. Before 5 p.m. means it is basically targeting the corporate customers, because corporate customers are working up to 5 p.m. How? The customer is currently measuring the delivery time and has agreed to share the data. Collect the data from customer. So nowadays online systems are there, like parcels. In parcel systems we have direct measurement of time which is coming, and at the end we are getting that your parcel has been delivered in this much time. So which includes picking and delivery time. Where is picked up the data at every customer location. So where is answered also here. Who? Collect from the customer. So where will we collect the data? We'll collect the data from both the customers. Data collection checklist. Now this is a checklist, simple checklist for collection of rejections, defects. And it is for a week, from Sunday to Saturday. For a week, this data is collected. Now what data is collected? The data is collected for Lester B wrap, and the location is New York. Time is from 17/1 to 23/1. So this 1 week data. Now what data are collecting? They are collecting the defect data. Here defect is rusted parts, misalignment in weld, improper test procedure, wrong part issued, film on the part, and so on. So every day they are doing the collecting the data. How many parts, how many defects are collected on Monday? Total 10. So rusted part is 9 and wrong part is 1. In this way, for Tuesday, total 13. 3 types of defects are there. Wednesday, total 3 types of defect, total 10. Thursday also 3 types of defect, total 5. Friday only 2 types of defect and total is 4. So we got here 2 types of data. What is it? First data is day-to-day data in total week, part wise and day wise. Like defect to defect data I got and day-to-day data I got. So rusted part 20, weld 5, and so we got total number of quantity for both the day and the defects, individual defects. Data collection tool, sampling. Now we understand that there are a lot of data generated even in the manufacturing, like people are producing 500, 600 pieces per day, per hour, per day. So like 100 to 150 pieces per shift. So everything cannot be measured. So we do sampling. So collect only a portion of data that is available or could be available, and using the data in the sample to draw conclusion, which is called statistical inference. So we use statistical tools for collecting and analyzing the data. Now why sample? Because I told you initially that it is not practical to measure each and every piece. It is a waste of time. It is costing too much, and the data also will be too much. So collection cost, time cost, and even data handling cost will increase. Sometimes data collection is destructive, like destructive in the sense like some of the packaging, like tea coffee package. So when we are collecting the data, so we have to tear that package. So the part is go wasted. It is called destructive testing. So in that case, the part becomes not usable. So sometimes the collection due to destructive testing, the data become more expensive. Then sound conclusion can also be made from relatively small amount. Now, this is very simple to understand that relatively that we can conclude about the batch from one part only, 1 or 2 part only. Like example, if I receive a part of coated, I received a part of nickel coated components 150 or 200 numbers. So if I see that 5-6 numbers are bad, then we can imagine, we can conclude that the complete batch is bad, because in some cases not only five parts will be bad, complete part will be bad. because it is a continuous process. So if in continuous process, if one thing goes out of variation and the process is not corrected, then the remaining parts will also be rejected. Now, two use of sampling. So first is process judgment based sampling. So like from a process, we can take multiple number of parameters. We call it basically parameters. So what is the first parameter from the process he has taken? He has taken the defect because he want to work on the defect reduction. So defect versus time. So he has taken the graph and where he want to do the improvement. Second parameter is cycle time. Cycle time is basically production time, how much time it is taking to complete one product. So cycle time also he is comparing with the time, like daily, what is the cycle time of the parts coming out daily. Then second data we are collecting like from population. So for population, we are doing random sampling because population is not easy to measure. Suppose if we want to know the choice of particular perfume from a city of people, from a city, so it is not easy. So we have to collect the samples like we do for elections. During our election for the states, for the country, we do the sampling, random sampling, and derive the results, probable results. Samplings types, like there are different types of sampling because how you are collecting the sample is also important because you have to define it. So there is first method is random sampling. Random sampling is pick up, like we are putting a hand inside a chocolate container and picking up the chocolate, whatever we want. So that is random sampling. Second is like we have a data, group the data. Group the data like we can say a machine. We have a defect. Hope my manufacturing example is fine for you. Hello?
Yes.
Yes. Because I don't know like people have been familiar with the manufacturing example or not. So like suppose a type of defect from a type of machine I've collected samples. From B type of machine I have collected samples. From C type of machine I have collected samples. And from D type of machine I have collected the samples. So like it is stratified sampling. Stratification is a process which is used, which is if you people have gone through 7 QC tools. So one of the tool is stratification. Like we analyze the data based on machines. We analyze the data based on department. We analyze the data based on type of products because data as a group looks big. But sometimes it may happen that one machine is faulty, one department is not doing good, or one brand of product is not working. So we do the stratified sampling to understand the data. Now process mapping. Process mapping is basically for every process, we have a process flow diagram. We call it PFD, process flow diagram, or process chart. Sometimes we call it process chart. So like for a manufacturing process, so first process will be receiving of raw material. In receiving of raw material, there will be a decision. Decision in a sense because when we receive a raw material, we have to check whether the material is okay or not okay. So we will take a decision, yes or no. If the material is okay, then we'll go to the next process. If the material is not okay, then we will reject the material and send back to the supplier and take some supplier corrective action at supplier end. Then after the raw material is okay, then it is going for like initial first process. Then first machine it is doing some process. Then second machine it is doing some process. Third machine, then it will go for final inspection. Even in each type of machine, there will be inspection stages to qualify that the machine output is right or wrong, means okay or not okay. So we will be using the diamond. Diamond shape is for basically decision. Decision is basically yes or no, whether to move to the next process or not. We call it as an inspection diamond also. Like we are doing the measurement, okay or not okay. It is the same. Then some places there will be delay. This delay is basically due to the cycle time. Sometimes in process we are not balancing the process. Like one process is taking 1 hour, other process is taking 45 minutes. So there will be 15 minutes of gap. So there will be a delay for the next process. So we will use the D symbol. We will use arrow for the direction of the process. Then we will have this document symbol. The document symbol is where we need to record certain value like number of parts produced. Suppose it is a diameter of the part. So what was the diameter of that part? What was the length of that part? How visually it was good or bad. So all the documents will be collected. And then end of the system where we will go for packaging, we'll go for dispatch. So this way the process mapping is there. I don't know why the link is not working. Okay, I'll show you. Just give me a second. The link is not working. Why? I'll show you an example of process mapping. See, this is an example of a process mapping format. Like which part we are doing, what is the process number, which shop floor it is, like what is the operation, machine number, description of operation. Then we will use this transport, storage, delay, operation,
Sorry,
inspection count.
sorry, I cannot see you. What is?
You're not seeing?
No, what are you showing now? We see the slide with the link.
Oh, you're not able to see the. Okay, let me see what is wrong.
No, maybe you are sharing only the presentation. You have to share your entire screen, maybe.
Now also it is not visible.
No.
Okay, what we'll do, I'll take a screenshot and share it on the group so that you will understand it. I think it should have been visible. I don't know why. I'm also surprised. I'll put in the.
Maybe you are sharing only the presentation, but
Ha
not
ha.
sharing.
No, I have to. I have like. Now you can see the presentation.
Yeah.
Yeah, I put that in the presentation. So like operation number. This is the template which we use for process flow diagram. So generally process flow diagram is not made by a single person. It is made by the group of people like quality, purchase, supplier quality, process production, dispatch. It depends which process we are doing. If you are doing of product, if you are doing of simple process, then it is fine. So is it visible? It is readable?
Yes.
I'll enlarge it little. Actually, I have put the link because it was not working. Now I think you can see it little clearly. So this is the company name, process flow chart we call it. We write the part number, process number, which plant is maintained, what is the model of this part, process flow number, and like what is the description of the part, at which stage of shop floor it is made, and which is the next process. So we use like it is like reviewed, made by someone, approved by someone. There will be revision. This is a live document. So it will have a document like document revision number, doc revision date. It is a cross-functional activity like quality, purchase, supplier quality. It depends who are required for this process. So content is like operation number 10. So what is the on what machine it is producing, description of the operation, then main flow or it is an offline assembly flow. Then we have to, this is very important because in this process flow, we are defining the product characteristics and process characteristics. Now, can anyone explain me what is the product characteristics and process characteristics? Can anyone give a simple example for that?
Again, what for what?
What is the product? What is meaning of product characteristics and what is the meaning of process characteristics? See, suppose we are defining an operation. Example, I can see I want to machine a rod of diameter 10 and length 10. So what I will do, I will first put it in a lathe machine or a CNC machine and run the set the program and run the program. So here the product characteristics, what will the product characteristics for me? See, see the name, what is written, product characteristics. So for a rod of diameter 10 into length 10, machining, the product characteristics will be diameter 10 and length 10 because we want it to see the same on the product. And second is the process characteristics. So in this process characteristics, in the process characteristics, we need to identify the process parameter. Like I am doing a machining in the CNC machine or a lathe machine. So what is required for me to achieve that parameter? There will be three parameters. Na? What speed the machine should run, what feed rate I have to give to the tool to cut the rod to make it diameter 10, and what is the speed, what is the feed, and what is the depth of cut I have to give so that I will achieve the required specification. So this speed, feed, depth of cut is for machining example. If I can give another example of a electroplating, or we call it passive 7-tank passivation process, like we have pre-treatment process. So suppose there is a degreasing tank. So degreasing tank, what is the function? We are dipping the parts before plating to the degreasing tank so that oil and grease will be removed from the part before it is going for plating. So if I see the product characteristics will be no oil, no grease, no dust. But if you see the process characteristics, in that case, there will be like what is the tank? Tank will be having some chemical. So volumetric concentration of that chemical is process characteristics. Dipping time, how much time the part has to be dipped to remove the grease and oil and dust. So dipping time will be the process characteristics. Sometimes we need heat also, hot bath.
It's done.
So we need.
You've sorted out everything. Have you guys done the?
So in process characteristics like tank, degreasing tank I was talking about. So what is the process characteristics? Volume of chemical, volumetric concentration of chemical, which will ensure proper degreasing. The temperature of the bath, which will ensure proper degreasing. The dipping time of the part in the bath, which will ensure proper cleaning. So these are the process characteristics example. Now Now the other term is like define the performance standard. Now performance standard is what? Performance is like output. So what output standard we want? So some of the definitions are there, unit. Now if you see the square block here, dais, it is like a dais with number 5, which we normally play dais 1. So this dais, there are 4 dais, 1, 2, 3, 4. So we are having 4 number. So number of parts, sub-assemblies, assemblies or system to be inspected or tested is unit. So here we have 4 unit. How much unit we have? Parts, 4 parts. Now second is the opportunity. Now what is the opportunity here? We have red dots, we have white dots. So we have 4 parts and each part is having 5 dots. So what will be the opportunity? 5 circles per unit. And if we calculate the total opportunity, 5 into 5, 5 plus 5, 10, plus 5, 15, plus 5, 20. So total number of dots is 20. And defects. Now here like they're calling it defect. Red circle is a defect here. And white circle is the OK. So defect is what is wrong in this dais. The wrong in the dais is it should be white, but it is red. Some circles are red. So defects, how much defects are there in this total 4 parts? First part it is 3, second part it is 5, 8, third part it is 11, and fourth part it is 12. So total number of defects are 12 in 4 parts. Now there is another term called DPU, defect per unit. Now what is defect per unit here? So total how many defects we counted? 3 plus 5 plus 3, 8, no, 3 plus 5, 8, 8 plus 3, 11 plus 12. Total defect we counted 12. Now unit, how much unit it was? There were 4 unit, 1, 2, 3, 4. So DPU will be defect per unit or defect per part. So how much is DPU? 12 divided by 4, which is 3. Now total opportunities. Now when we see of the opportunities, so what is the total opportunities we have? What is total opportunity? There are 4 parts into 5 opportunity in each part. So 4 into 5, 20 opportunities. Like red one is defect. So red one can be here also, everywhere also. So how much red one is possible? 20. 4 parts into 5 in each part. So 20 defects can be possible. So total opportunities. Defect per opportunity. Now defect per opportunity means total how much defect we got? 12 red dots. But how much was the opportunity? 20 opportunity. So DPO will be 12 divided by 20, which is 0.6. Now in the case of manufacturing, there are thousands of parts manufactured. So we cannot calculate this 600, 700. So what we do? We use a term called defect per million opportunity. Now it is DPMO. People use billion opportunities also. So it depends what is the highest unit you can go, because the production at production level it is we are producing like 1,000, 5,000, 10,000 or even like lakhs of unit per month. So defect, it's very important to have a higher figure. So we go for DPMO. Now what is the yield of Six Sigma? Yield means how much defects will be produced depending on the percentage. Now yield is defect, or what is yield? Defect upon total number of production. So for, if we call it our company, suppose we call company 3 Sigma. So what will be our opportunity defects? DPMO it will be 66,800 out of 10 million opportunities. Similarly, we call that we want 6 sigma. So why we want 6 sigma? Because our defect will be only 3.4 per million opportunities. So only 3-4 defect will be produced when we produce 1 million of parts. So similarly, this is a table which is showing as we go higher up from 3 to 6, the defect is reduced. Now 6 sigma practical meaning, if we go, now see the simple example here, 99% good. Then we are at 3.8 sigma. 3.8 sigma means 99% good. So what is, and here is 6 sigma is 99.997 we call it. Because more that we go out, then it is, we round off it. So 9997 is 6 sigma. 99.9997. So suppose if we are at 3.8 sigma, how expensive it is for us? 20,000 articles of mail per hour we lost. If we consider in terms of drinking water, unsafe drinking water for almost 15 minutes each day. 5,000 correct surgical operation per week. Two short and long landings most of the major airport each day. And there will be 2 either short or long landings if we go for 99%. No electricity for almost 7 days each month. 7 hours each month. So that is 99% accuracy. So if you go for 99.997 accuracy, 6 sigma, then in the same case, where we lost 20,000 mail, we will lose only 7 articles per hour. 1 unsafe minute in every 7 months. Unsafe drinking water. Here it was 5,000 incorrect surgical. Here it is 1.5, 1.7 incorrect surgical per week. Here it was 2 short or long landing. Here is 1 short or long landing every 5 years. Now here was each day from 99 to 99.997. This probability has reduced from 2 to 2 per day to 1 per 5 year. Then 2 lakh wrong drug prescription every year. It went up to 68 from 2 lakh to it reduced to 68. And now from like 7 hours per month, each month to 1 hour every 34 years. So this is the difference between 99 and 99.997. So how we calculate process sigma? So we have unit, we have opportunity, we have defect. Now the chocolate making company want to calculate the sigma value of the chocolate manufacturing process. You will find this example in YouTube also. They identified each and every day produces 1,000 boxes of chocolate, each carrying 50 chocolates. So during QC, they identified 25 defects in various chocolate. What would be the sigma value? So this will be homework for you. So please note it down or take a screenshot. Or if you want, I can take a screenshot for you. If anyone want any break or something, please let me know. Now everyone know that throughput. What is the throughput yield? What is throughput yield? What is yield? Can anyone explain? Am I audible?
Yes.
So what is yield? Yield is basically what is the correct number of parts out of total parts. So what we do, we minus the rejection and rework. So when we call about yield, we call it for a one process. And when we call a yield for complete company, like suppose a company is having three process, so A, B, C. So we calculate first pass yield for one, first pass with second, first pass with third, and then we combine all this thing. Like first pass field was like 6 unit scrap, 4 unit scrap, 6 rework. So total 10 unit minus. So out of 50 unit input was 50. So out of 50, 40 by 50 is 80%.
Sorry,
Okay.
again, what is yield again?
Yield is the good parts. Good production. Suppose I am producing, I am manufacturing in machine A. I am use 50 parts I am giving to machine A. Okay. Now machine A is what the machine A is doing. Machine A is giving me 4 rejected parts. Scrap means rejected parts. 4 parts are rejected in machining and 6 unit are reworked. See, rework unit can be reused, but we consider rework also in yield. Why we consider rework into yield? Can anyone say? Although rework part can be reused, is suitable for next process, but still we calculate the number in yield. Why? Why are we adding 4 plus 6 here? Can anyone tell? Hope people are understanding my language. There is no language issue.
Yeah, we understand, but we don't know. Tell us.
See, I'll tell you. Out of 50 units, 4 is scrapped or rejected. We cannot use it, right? And 6 unit we found wrong, but we corrected it. So even if we found wrong, even if we corrected it, still it is wrong only, na? Right? First time. First pass yield is what? First pass yield is okay part first time. So the machine is giving 10 parts rejected out of 50. So yield will be, first pass yield will be 40 parts divided by 50. 10 is minus in 40. So 80% is the yield of first machine. Now we see here 46. Even after 40 rejection, we see 46 piece we reworked. So this 6 piece got added. We never calculated it in real yield, but we have added in okay parts. So 46 out of 46, 0 is scrapped and 12 is reworked. So total okay by the machine is 34 out of 46. So 73.9 is the first pass yield for the part B. So how much it is? See, understand here, from 54 minus 46. From 46, 12 is reworked. So for C machine, 46 will be input. But here we will minus the yield because 12 parts are reworked, not at the first attempt it is okay. Now out of 46 part, 9 are scrapped. So 46 minus 9 is 37. So out of 46, 37 is reject. So 6. So yield for C machine is 80. Now this is individual yield. A yield, B machine, C machine. Now, but we will not see the machine na, when we are seeing the cost of the product. So what will we see? We will see the cost to the company, right? So the cost to the company will comprise of A machine plus B machine plus C machine. Because all the machine are company only, right? So we use the term roll throughput yield. We know because company level, a owner of the company will never see what is the yield of A or B or C. What he is more interested into, what is my final yield. So finally, I am getting like 0.8 into 0.739 into 0.84. So total rolled throughput yield is 47.5%, which is very bad. So when we measure it, this is why we measure it. So now we know where we are. We are at 47.5% in terms of machine A, machine B, machine C. So this is the measurement. Now roll throughput yield first pass calculator exercise. I am not giving you. Now when we talk about measurement, so we need to understand certain things in measurement, which is very critical, right? Because measurement itself is a complete science or complete subject, which we need to understand. So metrology means what? Metrology is the science of measurement. Each and every equipment has different working principles, different variations, different ranges, different least counts, right? So for measuring heat, we cannot measure it by vernier. So for measuring heat, we need thermocouples. For measuring length, we need measuring tape, vernier, depending on the size of the part. So metrology is science of measurement for determination of conformance to the technical requirement, including development of standards for absolute relative measurement. So what is metrological confirmation? Metrological confirmation is when we check an instrument, when we calibrate an instrument. So what does calibration give that? Metrological confirmation. So what is that? Set of operations required to ensure the item of measuring equipment is in the state of compliance with the requirement for the intended use. Intended, what is the meaning of intended here? Can anyone tell? Intended means what it is made for. What is the application here? So for measuring length, it will check only length, not other parameters. So before measurement, we need to ensure that the instruments are calibrated. This is the first principle of measurement. If the instrument is not calibrated, then we cannot claim that our measurement is right, and we may land up in doing wrong. So calibration, every instrument has to be calibrated before using it for any project. The set of if operation which establish specified condition. What is calibration? Calibration is we have a standard for each and every instrument. Vernier has a specific highest standard for calibration. Thermometer has an highest standard for calibration, where it is written how to calibrate a vernier, how to calibrate a micrometer, how to calibrate a thermometer, how to calibrate a torque wrench, different instrument. Okay. Measurement. What is measurement? We call it the technical measurement. Definition of measurement is determining a value of a quantity. So measurement gives us a value of a quantity, whether it is 10 mm, 10 meter, 20 meter, whatever it is. And measurement, what is measurement? Measurement is the part. What we are measuring is measurement. So hope the definitions are clear. The process of assigning number is defined as measurement process. So we are measuring something and the process is called measuring process. And the value which we get by measuring is measurement value. Now understand one thing. No measurement is free from errors. There can be measurement errors. Knowing where and how error occur in measurement process is essential for proper calibration. Okay. So we should understand how the error can happen. So what are the things we have to understand? Identify the error when they can occur. Example I can give, there are two people. If I call it technical people, if I call it office people and tell them to measure a length of an object with a micrometer or a vernier caliper. So who will measure it better? Who can measure it better, office people or technical people?
Technical person.
Because he is qualified for that. So eliminate the sources of error. Now what can be the sources of error here? He is using wrong instrument. The sources of error are only 3-4 types. We call it man. It can be related to man. It can be related to equipment. It can be related to measurement method. Right? Now in some instrument, what happens? We are using it continuously. Like you can see the measuring tape which we use at home or which we use at factory. The value like after some time of use, it is damaged. Right? So in some cases, like vernier caliper or micrometer, we are using contact measure. Contact measurement means the jaws are touching to the part. So there can be chances of friction, there can be chances of abrasion. The jaws can get damaged. So what will happen? A offset will be created. Suppose a vernier fall down. So what will happen? The jaws will get damaged. After certain period of use, after 6 months, 1 year use, vernier we are using continuously. So what will happen? Offset will be there. So we need to understand the offset and compute for uncertainty of measurement. There can be various uncertainty, like you don't know. There can be piece to piece variation, part to part, whatever it is. So we have to understand that uncertainty of measurement. Now MSA studies. MSA is basically measurement system analysis study, is study of a measuring instrument. So what is MSA include? We are not studying the instrument, we are studying the measurement system. Now what is measurement system compromises of? It compromises of man, equipment, method, everything. Right? Because anything can go wrong and we cannot say the measurement is right. So provide a criteria for accepting new measuring equipment. So MSA provide. What is MSA doing? MSA is telling us what is the criteria for providing accepting new measuring instrument, whether we should accept or not. Comparison it gives. It gives comparison like instrument to instrument error. 5 instrument we are using, each will have some error. So it will give instrument to instrument error. Secondly, we have 10 people online. Even the technical people we have. Some are very good in measurement, some are bad in measurement. Like example I can give, if I am doing a visual inspection. So eye sight of different people are different. So that can impact the measurement. Because they cannot read properly or they cannot detect properly. Sometimes color variation, color blindness is there for attribute measurement. So people variation will be there. Provide insight into causes of defect or defect analysis. Like measurement system will give you what is the defect in your measurement system. And it will even tell you that your part 2, there will be different component of MSA, like part to part variation, you will come to know that there is variation in the instrument. There is variation in the appraisal, like operator, or there is some different variation is there. So total variation is different and like part to part and appraisal variation is different. then we can come to know there is some special cause in the measurement, which will come to know later. Now, when we go for terms, we have like accuracy, precision, linearity, stability, repeatability, reproducibility, and gauge R&R. So we will see everything in few further slides. See, like where this is a possible sources of variation chart, where you can see that input is there, process is there, output is there. So once the raw material is processed, finished good is made. Now finished good is goes through measurement process. So there are observed process variation में two parts are there, actual process variation and measured variation. The actual process value, you can understand what is the meaning of the how can variation come in process? Tell me. Suppose I am machining a part in a machine. I am using tool. I am using coolant. I am using speed, feed, depth of cut. So lot of process parameters are there. Tool wear, suppose the tool is getting wear. Suppose there is some material variation in the raw material. So what will it give? It will give actual process variation. But when we see the measurement, we will give three types of measurement error within sample variation, sample due to gauge, variation due to gauge, and variation due to operator. Okay. Now, when we see the variation due to instrument, like gauge is instrument only. So we have four categories: accuracy, precision, stability, and linearity. And when we see precision, we go for repeatability. And when we see for operator, we go for reproducibility. Therefore, in MSA, we go for gauge R&R. Gauge is nothing but a measuring equipment. Now you understand this. There are two terms, like there are different types of errors. So one is location. Location means location error is there. Location means within that space. So location means within that part. So what will be the measurement in location? Accuracy. What is accuracy? This is the center of the part. So how close are we to the center of the part is called accuracy. Then second is precision. Precision means if we are measuring the same part 10 times. So how close are our readings to each other? Now here we are not concerned about the center. We are concerned about the reading closeness to each other. In accuracy, we are concerned about the reading closeness to the center. In precision, we are considered about the reading closeness to each other. Now see the top one. You see this circle, first one. Now the readings are close to each other also. And readings are close to the center also. Target also. So high precision, high accuracy. Now the second one, if you go, the precision is very high. You see this? All the readings are very close to each other, which means the precision is high, but it is away from the target. So accuracy is low. Although precision is high, accuracy is low. Now the third case is like if you go from this side, it is distributed everywhere, means neither it is accurate nor it is precise. Now if you see this here, so we see that as compared to second, this is more accurate, right? But when we see the precision closeness of each other reading, it is not precise. So hope people understand what is accuracy and what is precise. Accuracy is target, closeness to the target. Closeness of reading to the target is accuracy. closeness of reading to each other is precision. Now there is a term called bias. What is bias? We have a center, we have a target. So how far we away from the target is called bias. Suppose if my measurement is 10 mm, my center is 10 mm and I'm getting 10.5. So what is the bias? The bias is 10.5 is the bias because I am 0.5 away from 10. Hope people are understanding this. If you have any doubt, you can stop.
That?
Pardon?
I request to get back yes from this bias concept. Kindly go through it
So
again.
bias is this is the target value. This is the reference value. You see this? What is meaning of reference value? It is the target where we want. But where are we getting our center? We are getting it away from the center. Our center should be here, right? Our center should be this, but our center is here. So our center is shifting. So my center of the process is shifted from the target center. Am I clear? Am I clear on this?
Yes.
How away are you from the target? Simple word. Now we have seen the location error. Now we will see the width error. Now linearity term. There is a term called linearity. I give example of a vernier caliper jaws. Have anyone seen? With time the jaws get damaged. So what we do? We service the vernier. So what the service people do? They do lapping on the vernier jaws. So what happens? The vernier jaws are okay, but there is an error induced because we are removing the material from the jaws. So what will happen? Our zero error will not be there. It will not show zero error. Like when we close the jaw of the vernier, what will happen? There will be some reading shown because it is already abraded. Like so, this is called linearity, and linearity increases with time because after 6 months there will be when we buy a new instrument after 6 months there will be some wear and tear. After 1 year the wear and tear will increase. After 1.5 years the wear and tear of the touching parts will increase more. Okay, after 1.5 years so on it goes. So this is the measuring range. Like initially it was this, then it goes this, then it goes bigger, and every time it is adding on. So bias is adding on the range. Like I can say example, like I may see we are what are we doing? All the instruments are manufactured on the machines. Every machine has their tolerances, right? No machine is accurate, whatever you do. So for 100 mm there will be certain bias. For 200 mm there will be the bias will increase. For 300 mm bias will increase. Do you understand my meaning of that? So increase in bias over the measuring range. When we consider the length, so for increase in length, the error will increase. So that is called linearity. And what I was saying was stability with time. When there is an bias, if the bias is increasing with time, 6 months, 1 year and all, it is called stability. So this is time 1, time 2. The center is shifting. So this center shift is stability. Now stability is the ability of measuring instrument to produce same value over time when the measuring the same sample. like same part we are measuring, and after 1 year or after a certain period of time. So when we see this, there will be like stability issue. So as the statistical process control chart, stability means absence of special cause, which is indicated by control condition leaving on the common cause or random cause. Like special cause is not existing. What can be the special cause in the manufacturing material? Like suppose I am buying a raw material. The hardness of material changes every time. We don't know. Even though it is acceptable limit, but there is a variation in the hardness. Now what machine will do? The machine will make the adjust the variation, na? Because machine will not throw the variation, they will accept the variation. But it will have some variation. So that indicates that there is no special cause, there is only common cause. I will come on that topic later. In the SPC, we will cover that things. Now we have seen accuracy, precision, bias, stability, linearity. Now we will see the repeatability. Now the word indicates repeat. So what is repeatability? Variation in the measuring instrument. We call it equipment variation. When the same operator is measuring the same part with the same instrument again and again, suppose I am measuring a diameter of a bar. Even if I measure the diameter of bar at the same place, same instrument and same place, same way, I will get the reading different. Sometimes I will get 10.03, sometimes 10.04, 10.05, 10.01. So there will be variation. So that is called equipment variation. Because equipment is not a single piece, it is a assembly. So when it is a moving part assembly, so it will have some variation due to assembly. So it is called repeatability. So what is repeatability? Equipment variation. Now we go for reproducibility. Now equipment variation is repeatability and reproducibility is variation to the operator. Operator in terms means technical person. The measurement person, technical QC person. So it is called appraiser variation. What is appraiser variation? One technical person is measuring the same instrument, same part, but the readings are different. I understand the readings are not so different. It will be like 10.3. He may say 10.3. Other person may say 10.4. Second person may say 10.2. So variation is 0.03. But there is variation. So that is called reproducibility. So we have to take care of both. What we have to take care of? Repeatability and reproducibility. Because while measuring the data, we cannot know, like we cannot ensure that this person today who is taking the data will be available tomorrow also. Maybe he may be doing some other process. So I have to use a other person for suppose I have to take 100 readings. Today I told one technical person to take 50 readings. Tomorrow the technical person is not well or he has gone to the other place. So will I stop my process? No. What I will do? I will ask the other technical person to measure it. So what is happening? The variation in my 50 reading taken before and 50 reading taken tomorrow should not be so much. It should be within the specification. So that is called appraiser variation.